Hi everyone, welcome back to part 2. So for part B of this question, we have to find the values of time in which the depth is greater than or equal to 8.5 metres. So we'll begin by looking at our graph. 8.5 metres would be halfway between 7 and 10. And if I track horizontally across the graph, I'll find 4 intersection points which would line up at 8.5. And then if I track downwards from there, I'd be having time values approximately in these places. Now, we will do better than approximate. This is giving me a rough idea of what to expect. I expect 4 solutions to this. Now, we will be solving this one analytically. So we had depth of 8.5, which will replace the letter D in our formula. And as we saw last time, our equation was 3 by the sine of pi over 6t plus 10. So we have to solve this for t. Subtracting 10 from both sides, I would have negative 1.5 equals 3 times the sine. Now, instead of writing 3 times like this, why don't I immediately divide by 3? And then I'm just left with sine of pi over 6 times t. Now, negative 1.5 over 3 is going to simplify to negative 1 over 2. And I'll need to take the inverse sine of that value, and that's going to give me an expression for pi over 6 times t. Now I'm going to, not going to use tech for this one. I'm going to go back to my basics. So I have 2 special triangles that I have to memorize. I have an acute angle pi over 6, same as 30 degrees, and pi over 3. And this triangle has lengths 1, 2, and root 3. The other special triangle, which I don't think will apply in this case, is pi over 4 for both of these angles. Again, there's separate videos on this, which I've seen earlier. And then you've got 1, 1, and root 2. Now we're looking for a ratio, a sine ratio of 1 over 2. Don't worry about the negative at the moment, we'll deal with that soon. So if I want a sine ratio, I think this angle would have an opposite divided by hypotenuse of 1 over 2. Pi over 6 is going to be a key to this. Now, to deal with the negative, let's go to our unit circle. The point on the unit circle moves around from 0 to pi over 2 to pi to 3 pi over 2, and then a full cycle would be a rotation of 2 pi. As the point moves around the circle, the y-coordinate of the point equals the sine ratio. Now we have a y-coordinate or a sine ratio of negative a half. Negative a half on the y-axis is there. And that means I need a point on the circle over in that location, or alternately back in this location. Now if I draw in my little auxiliary triangles here, you can see that that matches the skinny triangle, which I've already highlighted above. Now, in order to be a triangle with a length of 1, we would simply divide that by 2, divide that by 2, divide that by 2. So we've definitely got here the right positions. Our small angle here is pi over 6. Likewise, the small angle there is pi over 6. But we need to know the angle here as the point had tracked all the way around the circle. Well, at that point, we tracked around to pi, and then we moved an additional pi over 6. At this point here, it's almost like we did a full rotation of 2 pi, and then we didn't quite make it. We were short by that acute angle pi over 6. Now, writing this as 6 pi over 6, then that is the same as 7 pi over 6, and writing this as 12 pi over 6, that's the same as 11 pi over 6. There's my first 2 results. So the inverse sine of negative 1/2 could be this number here, or it could be this number here. And that's only if I'm considering angles within the first rotation of the circle. Now we could have to consider additional ones. So let's write this out. Pi over 6 times t could equal 7 pi over 6. And to make this a general solution, I will include multiples of 2 pi as possibilities if we went further around. Alternately, we could have pi over 6 times t equaled 11 pi over 6 plus 2k pi. And I should note here that k is going to take the values 0, which is the ones we have there highlighted in green, or 1 if I added an extra rotation. Why would I want to add an extra rotation? Because back here on my graph, these results belong to the first cycle of the wave, to there. So that's the ones I've already written. If I added 2 pi, if I let k equal 1 and added 2 pi, I'll be finding those two solutions which belong to the second cycle of the wave. So we need to solve these two equations. So let's call this one equation 1 and this one can be equation 2. Well, from equation 1, if k equals 0, I simply get the 2 times 0 times pi would go. I have pi over 6 times t equals 7 pi over 6. It should be clear that t equals 7. If k equaled 1, then I'd have 2 pi plus 7 pi over 6. I might write a little bit of working out for this one. So I would have that pi over 6 times t equals 7 pi over 6 plus 2 pi. To add these, I would have to make that 12 pi over 6, and then I have pi over 6 times t is 19 pi over 6. The opposite of multiply by pi over 6 is multiply by 6 over pi, so I'll do that on both sides. These ones cancel, leaving t, and here the 6 and the pi cancel, leaving 19. So when k equals 0, my answers are 7 and 19. And that would match here. That would be the value 7, and there would be the value 19. Now, if you repeat this calculation, let's use equation 2, our second solution. Let's go with k equals 0. So if k equals 0, I literally have pi over 6 times t equals 11 pi over 6. T corresponds to 11. And if k equals 1, I have pi over 6 times t equals 11 pi over 6 plus 2 pi. Again, I'll express that as 12 pi over 6. So I end up with 23 pi over 6, and this was pi over 6 times t. Opposite is multiplied by 6 over pi, multiplied by 6 over pi. All of those cancel, and I have t equals 23. So the solutions for this one were 11 and 23, and I go back to check, and that matches there, and that matches there. To answer the question, when was the water depth equal to or greater? So let's highlight that in blue. So within the part we're looking at here, and then from 11 to 19, and then that little last bit there. So how would I write that? I would say 0 to 7. I would say 11 to 19. And I would say 23 to 24. These are intervals or sets of numbers. This is times. Time is belonging to this bit, union this bit, union this bit. So joining those together. And that's our solution for part B. That's the times when the depth of the water is equal to or greater than 8.5 meters. Okay, that's enough for this installment. Thanks for watching.